In this video, I'll show you how to solve the ALEKS problem called identifying combination, decomposition, and single and double displacement reactions. In order to successfully solve this problem, you need to know the definition of all four of these types of reactions, so let's start by writing that out. For a combination reaction, I'm just going to call it comb. For a combination reaction, we have two different reactants. I'm just going to call them A plus B, and they combine together to make one single product. The key thing that you're looking for in a combination reaction is that you start with two different things and you end up with only one thing, exactly like what we're looking at right here. We're starting with two different reactants and we end with one single product. This is an example of a combination reaction. A decomposition reaction is just the reverse of combination. So I'm going to just call it decomp. And in a decomposition reaction, we start with one reactant and it falls apart into two products. I don't have any examples of decomposition reactions here, but imagine this reaction happening in reverse. If I had the Na2O as my reactant and it turned into 4Na and O2, that would be a decomposition reaction, starting with one thing, ending with two. Moving on to the single and double displacement reactions, we're going to do the single displacement first. In a single displacement reaction, we start, this is a little bit harder to write out. We start with a single type of atom, just an atom, and it reacts with an ionic compound. So I'm going to call that BC. In the single displacement reaction, that ionic compound swaps places, the atom swaps places with one of the elements in the ionic compound. So it's going to give us something like this. So the A and the C are basically going to trade places. So that C is now going to be all by itself, and the A will have joined up with molecule B. So these two things here just trade places. That leaves the C molecule all by itself over here and the A molecule in this spot right there. Like I said, a little bit harder to identify. In the double displacement, we'll write that up and then we'll go look for them. In the double displacement, we have two ionic compounds. So we have AB and CD, two ionic compounds. Same kind of idea. We get one of the atoms from one compound trading places with the other, like that. So we're going to say these two trade places, the A and the C. So the A is going to move over here and the C is going to move over here, and that's going to give us C, B, and A, D. Little bit trickier to identify the single and the double displacement. So let's take a look at this reaction right here and see if we can figure out what it is. So one of the hints that I notice when I'm looking at this reaction is that in a single displacement reaction, we have a total of three different elements, A, B, C. And in this reaction, I have a total of three different elements, chlorine, potassium, and iodine. So that makes me think that I'm looking at single displacement. Does it match the pattern? So if I identify chlorine as my little A molecule, where does the chlorine end up in the product? It ends up over here. So I can see that the chlorine is trading places with the iodine. Iodine is ending up all by itself. This is an example of a single displacement. What about for my first reaction? Now this one is really tricky because it has polyatomic ions mixed up in it, so it really isn't following this very simplified format that I've written in this spot. But what I do notice when I look at this reaction, what I do notice is it is definitely not a combination because I have more than one product. It's definitely not a decomposition because I have more than one reactant. And it's definitely not a single displacement because I don't have any reactant that is just one single type of atom. It doesn't exist. So what I'm looking at for sure here is a double displacement where my copper and my zinc are trading places. Take a look at that. The zinc from here is moving over into this spot and the copper is moving over into this spot. These are tricky, but with practice, I know that you will be able to identify them.